Welcome to a presentation on how to store domestic hot water and combine the heating and cooling in newly developed MultiPACK heat pump chillers. The important thing with heat pumps is also that there is thermal storage, because then we can reduce the capital cost, because the installed capacities of the heat pump can be utilized to charge the storage device. Then this thermal energy storage device, it enables to supply sufficient domestic hot water even during peak demand periods, which have been accumulated during the rest of the period. And what is very important to understand how to charge these kind of thermal storage devices and the architecture, how to build up this infrastructure. In this respect, the thermal stratification in the storage tanks is very important, because the heat pumps are much more energy efficient if the return temperature is as low as possible. In some cases, reheating of the already stored water is needed, and I will show you some potential strategies to do that. This is an example of a heat pump on the left hand side, very simplified CO2 heat pump. There is an intermediate loop, an indirect loop, to divide or separate the high pressure CO2 side from the domestic hot water part of this side. In this case, I show you 4 storage tanks, which are characterized by having a serial connection. While the water is entering, the cold water can enter on the bottom part, and there has to be a specified diffuser to avoid mixing of the water, a jet flow into the tank. This must be absolutely avoided with heat pumps. So in case in the house there are a lot of water is taken out, then the cold water is entering the storage tanks. That's why it's very important to make this with a sufficient diffuser part. In this case, I show you empty tanks, meaning these tanks are unloaded and the heat pump starts. When the heat pump starts, around 10 degrees water, cold water is utilized. The amount of water is controlled, that the supply temperature is in this case 85 degrees. So this 85-degree water is entering a first heat exchanger. Inside it can be a plate heat exchanger or a tank or whatever, to reheat the circulated water to the building. If this is a hotel or other places, you always have a hot water circulation loop, and the returning water from the building has to be reheated before going back into the loop. And this preheating can be done with the 85-degree water coming from the heat pump, reheating the water, and maybe 10 Kelvin lower, the 75-degree water is entering the tank and is accumulated here. So the cold water is pushed and taken by the pump through the heat pump. After a while, you see that the tanks are fully charged, and this is detected by some temperature sensors, and in this case the heat pump will switch off, because the tank is fully charged. The return temperature of the water coming to the heat pump is increasing and the heat pump stops. However, the circulation in the building is continuously 24/7. In case there is not much hot water demand, the situation in the storage tanks will not change. However, the heat loss in these pipes circulating the hot water is continuously in place. So we need to find a measure to reheat water which is circulated to achieve sufficient supply temperature. This can be done by utilizing the remaining heat in the storage tanks, by applying a small circulation pump, introducing a circulation of water which is controlled to still maintain 55 degrees, for example, after this device. So we take out very hot water. Remember, 75-degree water from the tank is circulated the other way around in this heat exchanger, reheating the water which is circulated and pushing this water into the second last tank. So by doing so, we are reducing the temperature slightly in the tank. However, we can utilize the heat from the heat pump to do the reheating. We don't need any electric backup heating. And when there is enough demand, or the tanks are beginning to empty, or there's a lot of more cold water, then the heat pump will start again, and we can stop this pump, and it is normally reheated by the produced hot water all the time. The next example here is now a challenge which might happen if the operating conditions are changing during a day, during a week, or season of the year. And then it may happen, since this water column is going forth and back, heating up and being pushed back and so on, there might be intermediate water which is in a range of 30 to 40, 50 degrees inside these storage tanks. One way to reheat this would be to divide the gas cooler into two gas coolers. So there's the preheating of the water, which is always getting the coldest water from this part of the tank system. And you have the second gas cooler, or the first on the CO2 side, which is after heating and producing the, in this case, 80-degree water. The circulation pump is located in between, and this mixing valve is enabling to take a part of the intermediate temperature water and a part of this cold water back to the pump. By doing so, we can reheat relatively warm but not sufficiently warm water back to become hot water to be utilized. In the next slide, I show you another option where we now introduce the novel heat pump chiller from the MultiPACK project, utilizing an injector to have two temperature levels in the evaporators. And in this case, I also introduced a space heating heat exchanger in case this is needed. So that could be one option, even in between these two other heat exchangers, utilizing reheating and enabling an efficient reheating of cold, relatively warm water. We can also utilize even more of the heat in a dedicated space heating gas cooler. And in this way, we can connect the chiller heat pump to the storage system, distributing hot and cold water to the building while the hot water is circulated. The next slide shows a quite novel approach to implement even cooling provided to, if this is a multi-floor building with several flats, you would like to have an energy central in each of the flats. And the installation cost is also driven by how many pipes and circulation pipes we have. In this case, we propose to introduce a 4-tube supply system by having the hot water supply, the cold water supply, and return lines of both the hot and the cold water. By doing so, we can reduce dramatically the installation costs, and we can utilize the hot water to provide heating within the flat, which can be fan coils, floor heating, or activated walls, producing reheating an indirect loop which is inside the flat from maybe 25 to 35 to provide the heating, and returning the water back to our heat pump to be reheated. If hot water is tapped, it is also taken from this loop. By doing so, we can maintain the heat demand for each flat individually. On the same side, on the opposite side, we can cool with the cold water circulated in the building, and we can utilize the heat pump chiller to cool again, to take out this heat from the air conditioning into the hot water. This is one way to implement heat pump chillers with an efficient hot water storage, a very low capital intensive way to distribute and to be able to monitor and calculate the energy demand on each subunit individually for the flats of the building or hotel rooms or whatever it is. In summary, the hot thermal storage devices, they should be designed for certification and to avoid the mixing. It's very, very important with heat pumps. We need divided gas coolers to enable an efficient reheating of the water. And in the summary, in the conclusion, these heat pump chillers are well suited for high performance buildings in the future.